All right. Well, hi, everyone, and welcome to our Tech Talk with Women Who Code today. My name is Julia, and I'm evangelist with Women Who Code. And today I'm going to be your host. So in terms of our agenda for today, so we are going to start with a quick introduction about what Women Who Code is. And then we will proceed with our tech talk from Valeriia. And then we will have some time for Q&A questions. So a couple of points before we start. So just for your information, this session will be recorded, which we will then update to YouTube. So you can always go back and reflect again on the session. Also, please feel free to post any of the questions in the chat, and we will get to them during the Q&A session. I'll keep an eye on those. All right. So let's start with a quick introduction to Women Who Code. So I'm sure you're familiar with what Women Who Code is, but just to reiterate, our mission is to empower diverse women to excel in technology careers. And this mission is reflected with our vision, which ultimately is that we see a tech industry where diverse women and historically excluded people thrive at every level. This then is reflected in our values. When it comes to our values, we do focus on our mission and we take it very seriously. We always remember why we're here, who we are, and why we're here for. We design to inclusion. So day to day, we have so many volunteers who work so hard on making space and embody a culture of belonging. We proactively advocate for change. Through live leadership, we champion each other. And as a community, we indeed are very powerful. And we are all about journey forward. We recharge, we celebrate wins proactively. We're here for each other. And we're here for each other to ultimately break the barriers. And then in terms of little prehistory to Women Who Code, so actually this year we're celebrating 10 years of our community and 9 years specifically to Women Who Code. And today we have over 340,000 members in pretty much across the globe in 147 countries with 80 communities in specific countries, such as the one that we have in London. And it all started 10 years ago in San Francisco with a small community, and very quickly women and allies, people from across the world wanted to join us in our mission. Also, I wanted to point out that we have our code of conduct. So Women Who Code is an inclusive community, and we're dedicated to providing an empowering experience for everyone. So if you have any questions or issues, please feel free to submit an incident response form via the email that you see there. And if you want to get familiar with Women Who Code Code of Conduct, the link is just there. So feel free. And now I just wanted to tell you a little bit more about our volunteers and how it's structured a little bit here, Women Who Code. So first and foremost, we have leads. So leads, these are volunteers who are technical professionals who organize events in their area of expertise. And the subjects varies from all sorts of fields. This includes front-end leads, algo leads, Python leads, data science leads, so on and so forth. We also have our evangelists. So evangelists, these are our communication gurus. So these are volunteers who serve as brand ambassadors to Women Who Code. And their activities include anything from social media activities, planning social media strategy, deploying it. They participate in organizing conferences. So anything when it comes to brand, marketing, communication, we have our evangelists for. Also, we have our coordinators. So these are type of volunteers who volunteer for short term. So they help us to coordinate maybe some specific events or maybe some specific activities. So it's quite flexible and fluid. So this just gives you a taste of what potentially you could do if you have interest in joining our community. And then just a couple of words on the activities that we have planned. And as you may know, we're super active and we have activities and events pretty much every week, month to month, week to week. And one of the upcoming ones is the AdTech. So that's actually in-person events. So we organize not only virtual events, but also in person. Also, we have an event literally tomorrow dedicated to machine learning track that we have. So feel free to join that. And we're really also excited to announce that this week we're starting a LeetCode study group, which essentially is a 6-week sessions designed by our great volunteers who are experts in these fields, who pretty much want to help you to elevate your coding skills. So again, all information and events are posted on our LinkedIn. So stay tuned and always check them and attend based on your interest. And we do sincerely hope that it helps. So yeah, that's pretty much it from me. Thank you very much. And on that note, I'm going to pass to Valeriia, who will take you through the process of how to design and build Q&A processes. Thank you. Feel free to grab my screen, Valeriia.
Yes, thank you very much. And hello, everyone. And first of all, I would like to thank Women Who Code community for inviting me as a speaker today, and everyone the rest for being our guests. I'm going to share my screen. Can you see it? Okay. Can you see my presentation?
Yes.
Okay, good. We can start. So the topic of our Tech Talk today, as it says, is building QA processes from scratch, and the target audience here is relevant for both junior specialists and experienced professionals, because we will talk about building a QA process and a team from scratch, but it will be also useful for those who are already in QA or just in IT spheres, for our colleagues, developers, support engineers, and all others. And first, let me introduce myself. My name is Valeriia. I'm a senior QA specialist. I have worked in this field for more than 4 years, and it was pretty much the experience with 3D computer graphics industry, like 3D design and animation, and the application that's more or less relate to generating computer graphics. And I also have a background in software developing and automation. I used to write on C++, my own developed application, and on Python and Cypress automation tests. During my free time, I'm also a content creator. I'm sharing my insights on YouTube and Instagram, and you can find the links right here below. My YouTube is dedicated more to design stuff, where I'm sharing the process of creating designs and animations, while Instagram is more about QA and IT, where I'm talking about my work and all this Q&A stuff. Yeah. Okay, so today we're going to have 6 sections. We'll discuss the basics of quality assurance process. We'll define the basic terms like quality assurance, quality control, and testing. We'll see the difference between them. We'll also talk about the parts of QA processes like analysis, planning, documentation, and reporting. We'll see how to
Oh no, Apologies, some technical problem. We're back.
Sorry, I think I was kicked out. Yeah, I'm going to share my screen. What have you listened the last? I was talking about the content of our presentation.
Yes, exactly.
Okay, let's continue with it. Yeah, I was also talking about selecting tools and criteria for them, and adjusting CI/CD pipelines and what place QA takes in this process. And we'll discuss communication, style of business communication, mistakes, and some problems that can happen. Hello.
Hi. I think
Hi.
we'll have the same issue again.
Yeah. Okay. Is it good now?
Yes.
Okay, let's start from the basics. Yeah, so first of all, we'll define the terms. And quality control has been around for quite a while. Its origins can be traced back to the early 20th century. One of the pioneers in the field was Walter Shewhart, an American physicist. He developed statistical methods for industrial quality control while working at Bell Telephone Laboratories in the 1920s. And over time, these principles have been applied and adapted across various industries to enhance processes and deliver better products and services. And of course, it touched software development, where quality control lies in identifying defects or the behavior which might contradict or doesn't correspond with the business and functional requirements. Going further with quality assurance, it's slightly different process. It became popular in 1970s as organizations began to recognize the need for a more proactive and comprehensive approach to ensuring quality. So quality assurance involves establishing processes, standards, and methodologies to prevent defects and errors, rather than simply finding and detecting bugs and correcting them after production. So to draw a conclusion here, when testing and making quality control, we'll look for the existing bugs, such as unexpected behavior, bad user experience, or misunderstanding requirements, while quality assurance applies all its best practices to prevent defects in future by building and enhancing its processes. The quality assurance engineer is undoubtedly involved in the vast majority of the software development lifecycle, which you can see on our image. And there are 6 main stages of this cycle, and in the vast majority of it, the quality assurance is involved. So we can start from analysis and UI/UX design together, because software tester starts by ensuring a clear understanding of project requirements to set the foundation for quality development. Because how can we test if we don't know the expected behavior? That is why continuous collaboration with analysts and project management team is crucially important. The same with UI and UX designers. when the application is not responsive or it's hard to identify the purpose of any UI elements, it all makes user experience really bad. And not only are we able to clarify requirements, but we also make an influence on these requirements. Along with other business analysts, QA is aware of user needs and possible problems that might spoil user experience. So as a result of analysis, we plan our future testing. Creating a comprehensive test plan helps us outline testing strategies, resources, and schedules. For future, when other QAs join the project, it's a profound and useful document for faster and easy integration. The next stage of software development cycle is implementation. And while implementing, developers can address their questions about functional requirements to QA, especially if it's not the first iteration of development and they need to clarify some things. For example, if the bug has been got back from QA to developers and developer fixed it, or in the process of fixing, he should be aware of what's wrong, and if he or she understands the QA correctly. And the next stage is testing itself. It's absolutely obvious that QA is involved in test execution, making it smoothly due to preliminary gathered requirements and test planning. So when testing, we ensure that the product matches with business and functional requirements. And from my personal experience, I also include so-called ad hoc testing in each iteration of testing, which includes no planning or following documentation, just random scenarios that come to mind. And guess what? Each time it gives me at least a couple of fun issues, and they are really good. So this approach really works for me. And the next stage where QA is involved to is maintenance. So QA work doesn't end with deployment, because we maintain the product and user feedbacks even after releases. So long story short, quality assurance is integrated in most phases of this life cycle and plays a crucial role in software development. And here we're going to the second section of our presentation, which is called QA process. But first, let's remember what Agile is, because it's the most commonly used methodology software development in modern companies. So the Agile framework is an iterative methodology. After every sprint, team reflects and looks back to see if there was anything that could be improved, so they can adjust their strategy for the next sprints. And here on our scheme, you can see the stages of quality assurance. And the first one is requirement analysis. So as we discussed before, testing requirements is the inevitable and useful step in the entire QA process, because understanding requirements leads to a deeper understanding of product. So requirements should be tested as well as the product itself. And in these cases, QA coordinates with business analysts and project management. The next stage goes to test planning. The information gained during the requirements analysis phase is used for test planning. And a good test plan should comprise the software testing strategy, the scope of testing, the project budget, and established deadlines. I think it should also outline the types of levels of testing required, methods and tools for tracking bugs, and also some information about resources allocation and responsibilities to individual testers or other team members. Of course, if there are more than one tester in our team. And the next stage is preparing test documentation. And here we're talking about test cases, first of all. Just to remind you the main parts of a good test case, they are preconditions like testing environment, specific actions that need to be done to start reproducing this test case, steps and expected behavior. So as writing test cases can be time consuming, that's why it's better to allocate enough time for preparing them. But if you don't have a lot of time and the testing itself is an urgent and high priority issue, I personally recommend 3 approaches. First, you can write test cases only for the basic functionalities, cover just smoke scenarios, and then try some ad hoc testing or regression testing without any test documentation. The second option here is you can limit your documentation by checklists. They are also clear and they don't take so much time as test cases do. And the third, and I think the newest one, is you can ask for AI help, particularly ChatGPT. It will give a good output, which you can use at least while there's no time for writing test cases manually and more properly. For example, you can generate a request, something like write smoke test cases for testing one-on-one messenger as a web application, include steps, expected behavior, and preconditions. And ChatGPT will give a pretty good output. I personally tried asking him for test cases and got some good results. The next stage of QA process is testing, of course. So if we didn't miss all previous stages, we are good to execute testing properly. For example, testing the complete feature or any bug that has been pushed to testing for the first time or probably for the second iteration. And at the stage of testing, it's crucially important to keep in touch with developers and analysts, because if QA finds a serious issue, thanks to the flexibility of agile methodology, the bug can be fixed while other testing is performed. So it's very flexible, and this prevents from saving a lot of issues to be fixed. The next point is reporting. Reporting bug depends on what bug tracking system is selected on the project. And in some small companies, for example, fresh startups, it can happen that bugs are tracked to Google Docs or some other software, and there is no bug tracking system. So it can be a solution, but not so convenient at all. There are lots of tracking systems with free license or not so expensive with limited users. You can easily use them instead of some other tools. And I believe if we are talking about small company, it's a complete QA's responsibility to build a productive testing environment. And last but not least, automation stage. Between testing iterations, ideally, QA has enough time to cover necessary scenarios with automation tests. But it's only the theory. In practice, we don't have so much time at all. And that's why creating automation scripts is usually postponed. So since automation is a time-consuming process, only basic scenarios are better to be automated. at the early stage of product development. Try covering all smoke scenarios for the beginning, and then if you have time, add the scenarios from the extended path. And we're going to the next slide. And here you can see a web form of authentication. And I just would like to remind you the principles of choosing scenarios for automation. So let's look at our form. Here we have the header, the input fields, sign-up button, and also the reference to another feature. When you already have an account, you can try login. So what would I cover here with automation tests if I don't have a lot of time for automation? So first of all, we are going through the most basic and positive use cases when a new user is registered with valid data. That includes filling all inputs and clicking sign up button. Not so much, right? Additionally, I would include the verification of backend, of course. We need to make sure that our user is created and added to a database. So we're not verifying only the front end. And the second scenario here that's, of course, must be included to smoke test, and whether it's manual or automated, both of them actually. This is login, which you can see at the bottom of our web form. Even though it's another feature, but we are referring it to it from our tested forms. So that's why we need to make sure that we're able to open login form and authorize with valid credentials. So everything the rest doesn't go to the first iteration of automation. And what will be included on the next iterations in automation? Well, here, basically everything that you will be repetitively testing each time when you're doing regression testing. It's invalid data input like special symbols, some kind of JavaScript and HTML injections, or any other invalid data. Here, I would also include filling the form with one missing input, with all missing inputs, registering the existing users, and so on and so forth. So basically everything where your fantasy leads you and it makes sense in terms of regression testing. So when it comes to choosing automation framework for a product, the market proposes lots of paid and unpaid options. And here I highlighted the main criteria which I would pay attention to if I choose automation framework for my team. So the first one is price. As I said, there are pretty many free open source options which are very good for the starting small products, but can cause some technical support problems. On the other hand, open source code is better in terms of debugging any issues because you can see this code. You can try identifying what problem is and even try to fix it if you have enough resources for that. The next criterion for me is documentation and support. And they go together because it's good if the framework has a complete and clear documentation describing the main features and workflow, or if it doesn't have this documentation, at least technical support where you can address all related issues and you will get any feedback. The next one is scripts and data separation. What does it mean? So this means that automation test scripts are separated from input data store. For example, storing in XML or Excel files. So you don't need to do any modifications to the test scripts. The next criterion will be ability to be customized or to automate scenarios where which are based on multiple logics. Assume your application is so dynamic and your test scenarios are based on multiple logics. For example, if you click on A, then B should be visible, else then C should be visible. By A, B, and C, I understand any UI element or any other logic appearing model windows or something like this. Then you will need to develop your automation suite with your own methods, which satisfy your requirement. And to develop your own logic, the framework should provide its base methods. Otherwise, you can't do that. And the last, but I think the most interesting for me point is visual testing, because I personally use it quite often. Well, some projects have specific requirements on testing features visually, such as 3D engines, some kind of web design platforms. Sorry. Well, basically everything that has meaningful and editable visual assets. I personally use Cypress and its models for web application testing and Squish framework for desktop application. And in the next slide, I will show you and try to explain how visual comparison work. So both of before mentioned frameworks like Cypress and Squish, they or any other frameworks that work with visual testing, they have a system of verifying the percentage of screenshots difference and have a perfect visual representation of comparison between expected and actual results. And let's take a look at the scheme. So how does the visual regression testing work? In the first run, the script captures the actual image, which we expect to be a reference image. We don't have, at this stage, we don't have any references images at all. So we are like assigning that this image will be a reference because our application is currently working in correct way. Yeah, so within the next runs, the script captures the actual image and then pixel by pixel compares the actual image and the expected reference image. And as the output, it creates a diff image showing which areas of actual image do not correspond with the reference one. And before producing the output image, such frameworks for visual testing, they consider whether there is any sensitivity factor or any other values that user has specified before. Because sensitivity is also called threshold, and the sensitivity factor or value defines how strictly comparison should take place, what percentage of incorrect pixels that are not the same can be omitted. The higher the value, the lower the sensitivity is, and the comparison will ease out. Okay, we completed with QA process and going to the next section on building a team. And the bare minimum that each QA team should provide is, of course, manual testing. When we have a small QA team or we have just one software tester, the first thing that we are thinking about is manual testing. And here we can include all these types of testing, like functional, non-functional, as I mentioned before, ad hoc testing, and some other like load, stress, performance, and so on. But as for automation engineer, the basic requirements are a bit harder because if we're talking about the necessity of hiring a separate engineer for automation, that means that our product is not at its early stage of development. Because having an automation engineer along with manual QAs can cost pretty much money. But anyway, if we hire an automation engineer, he or she should have some work experience as manual tester. This is inevitable as these two close areas are interrelated. You can't be an automation engineer if you don't know how to test it manually, and you don't know the test basic principles at all. And the next criterion for automation engineer will be background in programming, but it's ideally, but anyway, at least the solid understanding of what programming is. And of course, expertise in any of automation frameworks. And such basic stuff that I think even can be omitted when we mention is like critical thinking or analytical abilities, attentiveness to details, which are also really important and a must-have for all software testers and I think IT specialists in general. And here we have like an approximate team members of medium and large companies. And they all need to have a team lead who is responsible for quality assurance in the company, test manager responsible for the quality assurance on any particular project, several manual specialists, because the quantity of them may vary, but for me, a comfortable combination is 1 QA per 2 developers. And of course, automated specialists, which we discussed before. And it really depends on the project and on at what stage of development your project is. Of course, for the initial and only started companies, you don't have a separate specialist for that. But if we're talking about medium or large QA teams, I think we really should bother about separate specialists for automation tests, because it can reduce costs of manual regression testing. So in this point, it makes sense. And here we have a proposed workflow of building a team. So what should we do step by step to build a good QA team? And the first step, of course, is prepare project documentation. Why do we need this? Because this documentation can be a good basis for onboarding and for hiring new specialists and for getting them familiar with the product requirements and all the processes that go in your company. The next step is assess resources and needs. Who exactly you would like to hire? What expertise level she or he should have? Some requirements for their background, technical stack, and the number of new employees that you're expecting to hire. The next point is selecting the right tools for your job. Because if we're talking about hiring new people and building a QA team, a separate QA team, if you don't have established processes and chosen tools and frameworks like bug tracking system, test management platforms, test documentation, automation framework, your CI/CD pipelines are not set up, it will be very hard to collaborate all together within your colleagues, software testers. And once we are all set up with the previous steps, so we have project implementation, we all have a technology stack and chosen tools and frameworks. We assessed our resources and needs. We're good to go and collaborate with recruiters and take part in interviewing. So this is just an approximate workflow. Of course, it can vary depending on your needs and on your project's requirements and so on. And in the next section of our presentation, we'll go deeper in detail about selecting tools, which we already touched on the previous slide. So selecting test management tool is crucially important, especially within agile methodologies where developers are explicitly involved in the testing process. And moreover, stakeholders and project management, everybody should be on the same page. By collecting all related issues in the same place, such management tools allow all team members to be in the context of what's going on in your project right now, who is doing which task, and so on. Such cooperation is useful because it keeps priorities of current tasks visible and help prevent the majority of defects from being pushed to release just by mistake. So on this slide, you can see a great variety of management tools for teams, which the market proposes. So these are ClickUp, Monday.com, Rocketlayer, Atlassian, and really lots of many others which are not in this slide, but yeah, the market is very wide. And to choose the right one that satisfies all your requirements is really important and high priority task when you're building a QA team or you're just starting software testing process as a sole QA. And we will talk about the criteria for selecting such tools. And the first criterion here will be integrability. What does it mean? It means that the selected tool should ideally have any train options like tutorial or tech support on how to get started, be ease of use, satisfy all project needs. For example, the feature to create sprint boards, adapt them to Kanban or Agile, depending on what kind of methodology you're using on your project. Yes, and this is integrability is very close to the second criteria, which is code customization. So here we're talking about the ability to set different task statuses, adjustable boards, screens, setting tags and labels for your issues, assign some employees to the task. It also makes the management tool very flexible. One of the primary drivers for moving to a test management platform other than Excel is that it allows multiple users to collaborate. However, when multiple users access the tool, challenges arise from tracking and security perspective. For example, one of the critical things to look for would be whether the task management tool locks a particular task case when it's being accessed, so that two people can't edit it at the same time. You should make sure that it really works this way. And the last, but I think not the least, of course, one of the most important factors is, of course, pricing, because there can be different subscription plans, and the cost of solutions should be looked into while selecting each task management tool. This involves taking into account not only the upfront amount it costs to buy a tool, but also a training cost, or implementation cost, or support, or anything that is additionally paid for this tool, for owning the subscription plan, and everything that involves working with this management tool. For example, I used some task management tool which didn't allow setting labels to tasks for all users. There was, I think, 2 or 3 free users that had an access to set labels, and it was okay until one moment when the team has grown, and we needed more users who are able and allowed to set these labels. So yeah. So besides such global tools as tools for management all project tasks, it's important to fill your environment with supporting tools and frameworks. And the first one here is a version control system, which is an absolute must-have for those who maintain automation tests and store test documentation, for example. The most popular version control system is Git, for sure, and it allows to track changes in any set of computer files, usually used for coordinating developers during software development, but also widely used by software testers to develop and maintain automation tests, as I said before. The next thing is integrated development environments, short for IDE. So these are the most popular: Visual Studio Code, IntelliJ, IDEA, and Eclipse. They provide a comfortable environment for writing and debugging code. IDE also support Git embedded to them, so when you're making local changes in the source files, IDE knows which branch you are in and which files exactly have some changes comparing to the previous version, and can be used to commit changes and push them to remote server. The next one is automation testing tools, and they have a significant impact on the final product, on the final quality of product. We touched the criteria for choosing the right automation tool in the previous section, but what should also be noticed here, I think, is that it all depends on what type of application you're developing, web, mobile, or desktop. They all have slightly different approach to testing and, as a result, automation. The most popular that are listed here is Cypress, Selenium, Appium, but of course this is not the whole list, and there are lots of them in the market. The next is API testing tools, and here I personally use Postman and their desktop version for my work. It's actually up to you web or desktop version you're going to use, But to make my work more comfortable, I create structural folders with different types of requests, depending on what feature I'm testing right now and what feature they relate to. This is also called a workspace in Postman, and it's easily shared between other team members. So it's if, for example, one team member changes something in this workspace, the second team member can see it in real time. So it's really comfortable and convenient to create these working environments in terms of API testing. And on this slide, we have two more categories left. These are communication tools like video or chats like Slack, Zoom, or Google Meet, which I use on a daily basis during my work, and time management and notes. And why it is so important? This is only my personal experience, but when I started using Apple Notes and Microsoft OneNote during my work, I became way more productive because all my tasks are listed there for each day, for each week, and I'm not stuck thinking what I forgot to do and who I should reply to and what else is on my plate today. And you know, these thoughts, they might be destructive. They don't allow to focus on your priority job. And in our next section, we'll discuss CI and CD pipelines adjustments. And first, let's define the basic terms and understand what's the difference between continuous integration and continuous development, because they pretty much always come together. So first of all, continuous integration focuses on the integration of code changes into a shared repository. While continuous development focuses on keeping releasable to production state. So it thinks, if we can say these words for development, but it thinks or considers this that ensures that the application is ready to be released at any time of the development. Basically, when it's needed, we can develop it to production, and it's only business solution, no technical issues. So this is what continuous development is focusing on. And in terms of frequency of continuous integration, this can happen even multiple times a day with each commit of developers or automation testers. When something is changed into the original repository and pushed to a remote server, we started running our build to make sure that nothing is damaged due to these changes. And talking about continuous development, this doesn't work after each commit because as it focuses on keeping and maintaining releasable state, we're just able to release at any time, but we don't have any necessity to release to production after each commit, each day, each developer does it. Yeah, so as a result of continuous integration and such frequent integration, this is an early detection of integration issues. And the integration problems are reduced by catching errors early in the development processes. And finally, the main outcome is consistent and automated way to verify that new code changes do not break existing functionality, which is rather useful for the process of development. As for continuous development, the software is always ready for development. And this is, of course, a good profit, and I think the most and basic purpose of continuous development. And the decision to deploy to production is relates only to the decision of business analysts or some managers, but we don't touch any technical issues. We don't set up everything from scratch each time we make major releases to production environments. So to sum up, the key differences between CI and CD are the following. In terms of scope, is that CI is primarily concerned with integrating code changes and running automated tests, while CD encompasses the entire process from code integration to delivery and may involve manual steps or approvals before deploying to production. And the key difference in terms of deployment is that CI doesn't necessarily mean deploying to production. It's only about ensuring code integration, while CD or continuous development aims to make the deployment to production or other environments seamless and reliable. So these are the main differences between these two terms. And the next slide is about the role of QA in CI/CD pipeline. And the most effective QA process is the one that is part of a larger continuous integration strategy. And in addition to speed, one of the key benefits of CI is consistency, allowing teams to catch bugs as early as it's possible in development. And verifying your work regularly with an automated build helps catch bugs quickly before they can sort of snowball into larger issues. And by using CI, dev and QA teams can spend pretty less time on testing overall. Manual testing can't scale to meet the demands of fast-paced development and often becomes a bottleneck. So maintaining an automated test suite is often the best option for developing a scalable CI process. Each release, whether it's manual or automated, should be automatically run and reported. So CI/CD and QA are two aspects that are designed to work together. This is because QA speeds up the delivery and deployment while helping resolve bugs. Continuous quality assurance is the perfect combination with continuous model, helping accelerate deployment while reducing costs. And furthermore, another role of QA in CI/CD pipelines is acting like a safety net, allowing development teams to focus on coding, making changes, and delivering updates instead of being involved in test environments and in test process. As we said before, QA plays a significant role in CI/CD pipelines, and one of the way of integrating QA to CI/CD is configuring the automation test project. And in the next slides, we'll get acquainted with some good example of YAML configuration file for a suite of automation tests. But initially, let's define what YAML is. So YAML is a human-readable data serialization language that is often used for writing similar configuration files. So here you can see the base example of a YAML file. And in YAML, key value pairs are defined and separated with colon. Keys are unique identifiers to which one or multiple values can be assigned. Well, actually, YAML is relatively easy to write and doesn't require lots of preparation and preliminary studying. But anyway, let's look at the example. This is a base structure which includes 3 stages of configurations, which are mentioned at the top of our file. And they are stages. These stages are build, test, and deploy. And define this stage this way, we can declare properties for each separate step. So as you can see below, in each job, the echo command is defined. Whether it's build, test, or deploy, once it's running, we'll get the script working, and we'll see the echo message building the application in case of build, running tests in case of test job, and the same with the third one as well. So yeah, going to the next slide. Here we have one more example. And this is the example of rules for running test suite depending on the past variable. And what does it do? So this sets the rules of triggering jobs on merge request, and depending on the value passed in the Boolean variable run smoke, it runs smoke or regression tests. And this code is from my real working project where I configured CI/CD pipelines on GitLab. This is, of course, very brief of how CI/CD can be implemented, as we can't encompass all aspects of build, triggering, and running within this presentation. But anyway, I think it's a good start. You can try it by yourself, practice a bit, because as I said, the syntax of YAML is not so hard for understanding. And by the way, you can always address your concerns and questions to ChatGPT as well, because I used it also for YAML, writing YAML files, and it helped me many times, and this help was really good. And the next section of our presentation is communication. So here I'd like to touch kind of more general but equally important topic, communication, which reflects the final results of the work of the entire team. So communication is usually understood as the process of exchanging information by verbal and non-verbal methods. And since the most part of our communication takes place online, then how we use verbal communication should be treated more attentively. Okay, and this slide is about how QAs particularly use communication and how I personally use it in my job. So, well, in lots of situations indeed. First and foremost, these are regular catch-ups like dailies, weeklies. The frequency of them can differ from team to team, but it allows to align the entire team with current issues and understand what's going on and what on their plate today or this week and what they are working on right now. After that, I personally use communication to, I think someone is not muted. Yeah, I think we're good to go. Yeah, so after that, I I personally use communication to clarify requirements, to talk to business analysts or project management, because it's an absolute must-have. Because if I don't know the requirements, I can't work, and I'm blocked with the further work. Yeah. So the next reason for communication, mostly with developers, is debugging any hardly reproducible issues that require specific steps or environments, or they reproduce only on my local machine. So we need to schedule a meeting, to have a call, and I am sharing the screen and showing how I reproduce these bugs step by step. And what I also use communication for is, of course, for one-on-one meetings. And yeah, the last but really often discussion topic for communication is whether this issue a bug or feature. I think some of you who work as software testers already, they know that this is inevitable parts of each software tester to prove to developer that this is really a bug. Okay, the next slide is about email etiquette. And here we have just general rules, like of writing a good email, and that it should have clear and concise language. Of course, because the recipient shouldn't read your poems for hours, include only the essential info, and don't forget to mention what you want from him. What is the purpose of your writing or your addressing this issue to him? And of course, a good email should have a strong structure, like introduction, kind of small talk if we're talking about offline, but anyway, some general phrases like "How are you?" or "I hope this email finds you well," and all this stuff. The body of email, where you explain why you're writing and what your problem is. The conclusion, what's your proposed solution, and of course don't forget about contact information and signature, because it makes your email more formal and helps the recipient understand who is writing and who to reply to. And of course, timely responses, if you got some email, are really important, because you don't want to wait for a long reply. The same with other people. They don't want to wait for your reply within 3 or 4 working days. Some issues can be urgent, so please keep thinking about it each time you get your new email or you update your mailbox. And one of the most important email structure is the mail subject, because there can be lots of emails in your recipient email box, and your email without subject can just be hidden or can be lost among others. So always include mail subject. And of course, don't be rude, don't be so nervous, don't include any abusive words or personal information, only neutral style, kind and soft. Yeah, and of course it's hard. It's really important to understand that not for each issue you should write an email. because some of them, some small issues, they can be easily discussed in alternative ways, messengers like Slack or some other that you have in your company, because it will take less time and makes more sense than writing emails, waiting for a reply, including someone to copy of this email. Yeah, so it's highly important to distinguish the purpose of your writing and the priority of this issue. If it's a very urgent issue, you'd rather create a group chat and discuss it in your messenger, message by message, or schedule a meeting, rather than starting emailing, which can take a longer time for this issue to be resolved. And this is it from me. Thank you everyone for coming and listening today, and I will be very glad to get your questions right now on our Q&A session or on my email. So you feel free to ask me any questions or problems that you're facing during your work. And thank you again for listening.
Excellent. Thank you so very much for such extensive and insightful presentation. I'm sure everyone enjoyed it as much as I did. And indeed, we had some questions coming in. So I'm going to start with the first one, if that's okay. So Daniel was asking if you could please explain what does a full stack QA entail? And also, if you could share what are the primary skills and programming languages other than Python for the role in QA.
Okay, yeah, I'm trying to find this question. Okay, yeah. So it really depends on what position we're talking about, because if we're talking about full stack QA, this is a person who should be able to do pretty much everything, like manual testing, automation testing, and leading a team probably, yeah, as well. So of course, we'll need some additional skills like programming languages and even knowing the algorithms and structures, all these tests that developers are able to pass, but of course not on so high level. But anyway, yeah, and yeah, talking about manual skills, this is an inevitable and must-have part. Yeah, and I would also say that you should be tolerant and attentive to details and be able to communicate with people, because when working as a QA, I collaborate with so many people. They're from project management team, they're from other development teams, they're analysts, and yeah, so you need to be tolerant to be able to communicate with other people, flexible, yeah, of course, not being rude, not being nervous, just simple, calm communication, and describing your problem and trying to find the best solution, because you're all working on the same purpose for delivering the best quality product.
Excellent. Thank you so much. I hope this answers the question. All right. Sorry?
I hope so too.
Yeah, excellent. All right. Next question. Mai was asking, who is responsible for the testing? Would it be QA or the developers?
Yeah, I think the pretty basic question. Of course, the final authority is QA, because QA is the last person who evaluates the quality of the product. But if QA gets the products in a not stable state. Everything is broken only because a new feature was implemented. This is not a very good practice because it means that the developer didn't test its code at all, and how his changes affected the rest parts of the code. So in this sense, they're both responsible for it. But as a developer, we should understand and ensure that we are providing the code at least tested for basic scenarios, which we think that might be affected. But it's the QA's responsibility to apply all the testing practices to like some unusual scenarios when you're just hacking the app and trying to crash it. Of course, the developer doesn't have to do it. Yeah, so in this sense, they both are responsible for their work.
Okay, excellent. Thank you. And next question is about project documentation and specifically before hiring. So one of the attendants is wondering, doesn't it take too long to prepare project documentation? Maybe about practices around that?
Yeah, of course. Here we should estimate what kind of documentation we're talking about and the level of detail, because the test plan can take like 20-30 pages with all the written testing strategies, tools, and so on. But we should make to give a general idea of how all our process are going in our team, so that it would be easier to a new hired person just to familiarize themselves with basic scenarios, basic features, basic goals that we are all moving to. So yeah, depends on the level of detail and how much time do we have.
Excellent. Thank you. So the next question is from Tanya, and she's asking if you could elaborate on the usage of Selenium framework versus Cypress and Playwright, and which one would you recommend to start for someone who's learning automation?
I would personally recommend not any particular framework, because it's really not so important. And I can explain why. If you want to become a good automation engineer, you need to acquire first programming skills and the overall understanding of how the applications are structured and how they are developed, and how and what automation testing in practice means, what are locators, how to get them found, and all this stuff, rather than focusing on any particular framework, because there are so many of them in the market. You wouldn't ever guess what framework you will need on your next position. And it's not even about programming language, because when an automation engineer is able to work at least with one automation framework, I think he will be easily get acquainted with different frameworks that are required on his new job. That's exactly how happened to me when I changed my job and started using Cypress from scratch. But I had an overall view of how all automation works, and it having all documentation and Google, it wasn't so hard for me to get familiar with it. But of course, if we're talking about particular frameworks, Cypress is quite modern, and the level of the entry level of starting to work with it is pretty good. So I would recommend looking at this framework. But anyway, it's only after getting acquainted with all programming skills, solving some problems, and so on and so forth.
All right, thank you. So next question is from Georgi, and that's quite extensive. It's quite a bit of questions, actually. So I'm going to read it out. But so do you have experience of using any test management tool that automatically flags the tests that are affected with spec update? How do you manage the procedure of auto test updates? Is it manual on every step, or test update task is assigned to automation engineers fully automatically, and you don't need to intervene?
Yeah.
We can go one by one. So do you have experience of using any test automated tool that automatically flags tests that are affected with spec update?
Yeah. No, I don't think that I have a similar experience, because if you mean requirements by spec, we have never integrated the spec or requirements to any management tools, because we just simply didn't have enough time for that. Yeah, so I think no experience, but yeah, I think this topic should be more attentively Googled and researched. Yeah.
Definitely, thank you.
But
So,
a good idea for my new posts on Instagram, for example.
yeah, or for a next tech talk.
Yeah. I'll note it.
Excellent. So going back to the CI/CD discussion, and what you've told us, Elizaveta is wondering, how could CI and CD exist without automation tests? Is it possible at all?
Not so clear question for me, because what do you mean then by CI/CD? What should it do? Of course, CI/CD exists in each project if we're talking about development, and if we don't have automation tests, the CI/CD pipelines anyway are set and adjusted for building the source code for each commit or for each release. So yeah, in this sense, why not?
Okay. I hope, Elizaveta, this answers your question. If not, let us know.
Yeah, I hope it doesn't contradict with her question, if Elizaveta is with us.
I'm not sure. No one is pinging, but maybe that's a good sign.
Okay.
Right. So then Sophia is wondering, and she starts her question with saying that QA takes part on requirements revision, but it's the product management that should prepare the specifications, or is it QA too?
I would say that it's their collaboration, because the project management spends lots of their time to research what there is, what similar products there are on the market, and what user gets used to, and what the user is expecting. And in this sense, the project management is responsible for not so particularly creating requirements like one by one, but at least for getting the idea of what is expected and what direction we are moving to. But yeah, QA also takes part in requirements revision, and but it's more like iteration of testing, because as I said in my presentation, we are testing not only product but requirements as well. So we're like estimating and evaluating the output of project management research, and and give our view of it, because we also consider the user experience each time when we touch the application in terms of testing.
Okay, thank you. Thank you for your answer. And I think we have a last question for tonight, and that's from Tanya, and she's wondering, as a QA automation engineer, is it necessary or not to know HTML, CSS, and GS? If yes, then to what extent should we learn these skills? And if you could please recommend any resources to learn from QA automation perspective.
Yeah, very good question, I think, because during my previous work experience, I used to work with web application and desktop applications. And on my previous job, I worked with desktop applications, and I even had no idea of how HTML and CSS work and what JavaScript do. Of course, I knew about this technology stack, but I didn't use it at all. So what I want to say here is that it really depends on what type of application you are testing. Of course, if you are on your early stage of career and you are just preparing yourself and building your portfolio and resume, of course, these skills are really popular in the markets, and it's really good for you and a good point if you know them at least at basic level, and you always can solve any problems on lead code. And for JavaScript, I know that they have their own JavaScript practice training website where you can solve problems and together with just testing your code and to see the output of this code. So yeah, if you want to expand your knowledge and to expand the technology stack, of course, these are, I would say, the key skills for a software tester, besides testing itself. Yeah, and if you're working with web application, as it happened to me after my changing my job, I had to learn everything from scratch, like what HTML is, how to write CSS objects, and what API testing is. So yeah, it's better to start now, of course, rather than postponing it to a later date, especially if you have time.
Excellent. Thank you very much, Valeriia, for your answers and for the presentation. So there's no any other questions coming in. I assume we exhausted all of it. So yes, and we're pretty much approaching to the time. So once again, Valeriia, thank you so much for your time and for sharing your insight and expertise. I'm sure everyone found this incredibly helpful and useful. Also,
yeah,
thank
you very welcome. Thank you for inviting me.
Absolutely. Thank you so much again. And thank you everyone for joining. I hope you enjoyed this. And yes, stay tuned with Women Who Code activities, tech talks, and all other stuff that we do. We hope this was useful. And yeah, thank you. I'm going to close the session now.
Hope so too. Thank you, everyone, and bye-bye.